Example 5, we are deriving the square root of 4 plus 2x. Okay, so we're getting a little bit more tricky here because we don't have a power, we don't have a trig function, we have this radical that we have to work with. But once you know how to manipulate radicals using exponent rules, this becomes really easy. So the outside function in this case is going to be that radical, okay? But it's going to require a little bit of manipulation. So the outside function is the radical. Okay, the inside function obviously is the thing on the inside of the radical. Okay, as I mentioned in the last example, when you're trying to find the outside function, it's usually going to be an exponent or a radical or a trig function, and the inside function is usually the thing on the inside of parentheses or inside of a radical of some sort. Almost always that's going to be the case. There are weird cases where that's not true, but we'll go through those as you move through these examples. So the inside function is 4 plus 2x. So now how do we handle this radical? That would be an excellent question to handle here. Turns out a radical is the same thing as blank to the 1/2 power. So we're going to manipulate this a little bit so that we have this inside function is 4 plus 2x to the 1/2 power. The reason we do this is because now we know how to deal with it in terms of the power rule for derivatives. Power rule works no matter what the exponent is. Okay? So how do we derive this? We have to derive the outside function first. That is this parentheses to the 1/2. So what we do is we're going to take that 1/2, we're going to bring it down in front and subtract 1 from the exponent, just like what you normally do with the power rule. So this gives us, let me do this in green, 1/2 with the stuff on the inside to the minus 1/2. Okay? Then you copy paste the original inside. Nothing changes about it. Nothing. Okay? And then you multiply by the derivative of the inside. So the derivative of 4 plus 2x is 2. Okay? So at this point, since all you were asked to do is derive this function, you could call it quits right here. If it said derive and then simplify, let's continue. So notice that we have a bunch of multiplication here and a little bit of division with this 1/2 out in front. And also, we have this negative exponent that we have to deal with. So when you have a negative exponent, that means you have to move it to the opposite place of the fraction. So if you have a negative exponent on the top of a fraction, or if there is no fraction, it gets moved to the denominator and then has a positive exponent. Okay? So simplifying this, we have 1/2 times 1 over 4 plus 2x raised to the 1/2 power, because of the negative exponent, times 2. All I did was manipulate this thing in the middle. Okay? Since we're multiplying these things, you can multiply straight across the top and bottom. So what this gives you is 2 over 2 times 4 plus 2x to the 1/2. Know that 2 cannot be FOILed inside this set of parentheses here because it's locked inside the 1/2 power. But what we can do is we can cancel the 2 on top and the 2 in the denominator, just using fraction rules. So the last step with this is going to be 1 over 4 plus 2x to the 1/2, and you're done. That's it. Even with all the algebraic simplification, it's not too bad. You could have definitely stopped up here where the colored stuff is. That's the derivative part. The rest is just algebra. 90% of calculus is algebra. If you get your algebra right, you'll do extremely well in calculus. Okay? So that was example 5.